Well, welcome everybody. I know we have an action-packed schedule for CloudSecNext, so I've got a lot of slides here, and we're probably going to skim through the majority of them and hopefully have a little bit of time for Q&A. But I'm really excited to talk to you all about some experiments that I've been doing related to GenAI and vibe coding and how it could potentially help us out with the inherent problems associated with multi-cloud security. As Eric mentioned, we co-author a class, Sec 510. The new name of that course is Cloud Security Engineering and Controls. If you've taken Sec 510 before, you know we've been through a couple of different titles in the past. Hopefully this one's here to stay, but it's the same great content with a lot more as well. And a lot of the new content is related to GenAI, and a lot of that we're going to be sharing today. So if you're interested in the topics we're covering here and you want to learn more, check us out at sans.org/sec510 and check out our free course demo. So let's get into it. We're going to start off by talking a little bit about GenAI use cases and both the ineffective and effective use cases. We're going to talk about the inherent problems related to multi-cloud complexity. This is a topic that we discuss a lot in the course, considering the fact that one of our taglines is that multiple clouds require multiple solutions, and you'll understand why shortly. I'll then explain the experiment that I did over the course of several weeks, what worked, what didn't work. We'll talk a little bit about the security risks. Then I'll do like a 5-second demo of what we came up with, and then leave us with some additional resources in Q&A. So let's just set the stage. Let's talk a little bit about GenAI. I know that a lot of these terms have probably been mentioned a bajillion times in this summit over the past 3 years as well. So let's just get the definitions out of the way to make sure we're all on the same page, and then we're going to ignore them completely going forward for the presentation. So when I say GenAI, I'm referring to artificial intelligence that can create data that's outside of the training data. This is the more creative AI. And the reason why I want to mention that is because traditional AI is still here. It's not going away anytime soon. And it has some use cases that are honestly, it's better at dealing with than GenAI, as we're going to give a good example of that momentarily. LLMs are applying GenAI to natural language processing, which allows us to communicate in a natural language and get it to respond. These are via prompts that we provide to the GenAI models. One of the core issues that we have in GenAI, and this relates to security, is hallucinations, where the AI will get something wrong. Now, I, generally speaking, whenever I'm talking about anything, I try to be really humble. I don't know everything. I don't like to make definitive statements. So if you ask me a question during the Q&A, I almost guarantee you that I'm going to say something like, I think that's the answer, or that makes sense, or I don't know, but I think that it might be the case because of X, Y, Z. GenAI doesn't do any of that. GenAI tells you that this is the answer. It doesn't give you any caveats, doesn't give you any percentages of confidence. It's just always confident, even when what they're saying is nonsensical. And this could be very dangerous if we are depending on the outputs of these GenAI platforms, because if we're making a decision based off of a hallucination, that's going to potentially result in a security issue or a safety issue. And anytime that someone says that we can eliminate hallucinations altogether, I want you to replace the word hallucination with misinformation. If someone claims that they can remove misinformation from their platform, they have solved a fundamental problem with the human species, and I think you should give them the Nobel Peace Prize. Odds are they have not actually done that, and they're just trying to use some magic and marketing stuff to get you to not worry about the confidence that they have in their platform. But one thing that can limit hallucinations is this concept of temperature. This is a parameter that affects the randomness of a GenAI response. And that's important to us as security professionals, because if we're using GenAI output to make security decisions or development decisions or operational decisions, we don't really want the platform to be creative. We want it to be very scientific. We want it to give us a relatively consistent result every time. Reducing the temperature does not eliminate the randomness, but it certainly restricts the level of randomness that it has. So let's talk about how LLMs can be useful for security. I want you first and foremost to recognize every time a vendor tells you that they're using LLMs for security, really try to understand how and why. Because everybody's trying to put AI into every single platform. I actually saw this morning. I got to share this with you. It's so funny. I couldn't even contain myself. I was looking at a plan selection, how you can select from an enterprise plan or a free plan for a given product. And the headline of this page was an AI powered plan for every business. What the heck does that mean? An AI powered plan for purchasing a product? People are just throwing around the word AI like it's going to solve all of our problems. When in reality, not only is GenAI not going to help with everything, but there are also cases in which traditional AI does a lot better than LLMs. For those who know me outside of the technical space, I like to play chess. I waste a lot of time on that game that I am really just plateauing on. But the reason I bring up chess is because this has been a game that's been played by AIs for decades now. Back in the 90s with IBM's Deep Blue, chess bots were proven to be able to beat even the world's best players, beating Garry Kasparov, one of the best players of all time, in a match. And they've gotten so much better than they were back then over time. Now, if you compare that to GenAI, if you have the best chess bot play ChatGPT, people have actually done this before, and ChatGPT will just hallucinate moves, make completely illegal moves, and basically cheat the entire game and somehow still lose. So this is a good example of how if we have a well-known solved problem that requires, or not solved, but like well-defined problem that has basically no context-specific considerations, traditional AI might be better than Gen AI to solve that problem. An example that's specific to security, software composition analysis, the ability to look at your code base and make sure that your dependencies have no known vulnerabilities. I don't see how Gen AI can help us at all with that problem. And in fact, it could actually hurt us because the databases that they depend on require real-time data. And by definition, LLM models, at least the models themselves, are stale. They are trained, and then that's all of the data that they have. And unless you're using something like retrieval augmented generation or RAG, that's a snapshot in time. So using that to do something in real time doesn't make a whole lot of sense. Now, it might be helpful in some other areas like static analysis and dynamic analysis, but it's really not that clear because I think that Gen AI is most useful for context-specific operations. And I'll give some examples of this. And also using LLMs to search through documentation. Eric's shown some examples in the past as to how this can give just bogus results and how this could be very dangerous if you're depending on those results. So one of the things that I like to say is that if the benefit gained from using Gen AI does not outweigh the risk of hallucinations, it is probably not the right tool for the job. You need to genuinely evaluate that trade-off. And if the answer is, yeah, there's some hallucinations, but the value that we get out of trying to use Gen AI is tremendous, well, there you go. Use Gen AI. But if you don't have a compelling use case for Gen AI, you're only risking the possibility of hallucinations. Why would you want to add that to your list of already very significant problems? So now let's compare this to some potentially more effective use cases. So I think that the places in which Gen AI can really help us is take organization-specific requirements that use English or some other natural language to define and translate it into code. I think it is very promising for defining and translating IAM policy because while I'm a developer, I know that not everybody is a developer, yet they may be responsible for IAM policy. If we can use GenAI to effectively translate our business requirements to code, I think that the benefit there is tremendous. The same thing is true for infrastructure as code, which is going to be the main focus of this talk, and automated abuse case testing. I could be talking about that for years, but maybe I'll save that for the Q&A if we have time. This allows us to introduce context that a general tool will not have. So if there's something that requires business context, GenAI may actually be preferable over other tools. But if it's a problem that is generally well understood, that is going to follow the same process from company to company, maybe GenAI should be pushed to the side for that particular case. That being said, security must validate the responses from these LLMs. Otherwise, we're going to be potentially making tremendous mistakes. And that's why it's important to understand things like IAM policy and infrastructure as code in order to use these platforms effectively. And that's part of the reason why we cover these topics so much in Sec 510, Cloud Security Engineering and Controls. I'm training myself to use the new title there. Now let's talk about the inherent issues with multi-cloud complexity. It is already really hard to deal with one cloud provider. When you introduce multiple cloud providers, you get the complexity that we demonstrate in this little pseudo math formula that I put together. So let's say we have to support AWS, Azure, and Google Cloud. Well, the effort to support 3 providers is the effort to support provider 1, provider 2, and provider 3, divided by the overlap of concepts. If you know AWS, it's going to be easier to learn Azure than if you've never worked in the cloud at all. But I think you're going to be surprised to learn how little overlap there is between those concepts. Not to mention the effort to integrate these systems is tremendous. We have an entire section in our course that is all about third-party vendor integrations. And that also relates to CSPM, as Paul was talking about in the previous conversation. In order to have your systems talk to CSPM, that requires some multi-cloud integrations, which are inherently complex. A lot of people think we can solve this problem with cloud-agnostic solutions. VMware defines cloud agnosticism as a cloud design strategy in which applications, tools, and services are designed to migrate seamlessly between multiple cloud platforms or between on-premises and cloud in a hybrid model without disruption of service. In short, it allows us to create a workload, take it from AWS or on-premises, and put it in Azure, and it's just going to work without any issues. And with cloud agnostic security, we could follow the same principle of we apply the security strategy to one cloud, we can migrate to another cloud, no problem. The problem is that cloud agnosticism isn't real. A lot of people will tell you that there's such a thing as cloud agnosticism. I guess they're technically right to some extent, but in reality, it's not really a thing. And the reason why that is that even though you can use, let's say, Kubernetes is a cloud native tool that a lot of people reference. You can run a workload in Kubernetes and move it from cloud A to cloud B, but the Kubernetes workload is going to talk to other cloud services. How are you going to migrate from one cloud service to another? Going to be pretty difficult, at least without some tools to help you out. So if you want to truly be cloud agnostic, to have the same application run in multiple clouds, you either have to avoid using those cloud-specific services, which basically eliminates the benefit of using a cloud provider in the first place, or you have to rewrite the workload multiple times to work with different cloud services. Gartner agrees with me to some extent. They say that there are not many obvious ways to avoid concentration risk while keeping the benefits of cloud services. So the question then becomes, can GenAI help? And if so, is it a replacement for the kind of work that we do in the cloud security space? So to answer this question, I created an experiment. My goal was to use GenAI to convert the lab environment that we use in Sec 510 to use Oracle Cloud. Now, I know nothing about Oracle Cloud. Prior to doing this experiment, I have never even logged into their user interface. But I do know AWS, Azure, and Google Cloud, and our infrastructure is all defined as Terraform code. So our goal is to see if GenAI can help us convert our Terraform code and our application abstraction layer to use Oracle Cloud as automatically as possible using GenAI, and then to learn a little bit about the security implications of doing so. Now, it's kind of funny because as soon as I started this experiment, there was a huge Oracle breach that happened. That's kind of outside of the scope of this conversation, but I thought it was kind of funny. And if you're looking to migrate from one cloud to another, specifically talking about Oracle Cloud, all the cloud providers have their advantages and disadvantages. This might be something you want to read up about before you make that decision. So now let's talk a little bit about the infrastructure that we're working with. Our lab environment is real infrastructure for a fictional company called Nimbus Immutable, and it is built using Terraform as well as the cloud software development kits for cloud-specific service integrations. And as you'll see in our demonstration, if we have enough time for it, we have the application. It looks like it's running the exact same software. It operates identically. It looks the same. But in the background, it's using the cloud-specific services and the cloud infrastructure. And it's so seamless that sometimes we can't tell as to which cloud provider we're on. So we put in the tab the icon and the title associated with the cloud provider that the student will be using in that lab environment. So let's start off with some of the experiments. The first one and the most obvious one to people that are familiar with GenAI, but maybe haven't gone past the basic tool set, is just have ChatGPT do it for us. Let me give ChatGPT all my code. Let's tell it what to do with it. Let's see what it gives us back. So I gave it, using an enterprise account, my entire Terraform code base. I said, unzip it, convert all the files to Oracle Cloud, and rezip it. And it looked like it understood the request. It gave me a very detailed response, and it gave me a link to download the files. It sounded beautiful. And I also told it to do the same thing with our JavaScript application layer, which is going to be able to make the service-specific calls from our app to the cloud-specific services. Here's the problem. It didn't work. Didn't even come close to working. When I did the deployment, I got 149 errors, which is a lot for the size of this project. But more importantly to me is not only did ChatGPT fail to do the work, it also just didn't do the work in many cases. It just ignored complete blocks of code and left it alone without telling me. It just didn't change. It did not convert many of these resources. This gets to the point of hallucinations. This is kind of a hallucination by omission. The platform did not do the thing that I told it to do, and it didn't tell me that it didn't do the thing. So now if I try to deploy it, I'm going to have a bunch of AWS resources and Oracle resources when I only wanted Oracle resources. Bizarre and frustrating. And then I went from file to file and I said, let's try to make this work. It just didn't work. It was frankly worse than useless. It was a complete waste of time. So after that, I was very disheartened. I thought, maybe this experiment's not going to go anywhere, and maybe I should just quit there. But I said, you know what? No, I'm going to push forward. I'm going to take a smaller step here. I'm going to convert everything from Azure in our lab environment to AWS. And the reason behind that is that Azure has way more documentation and third-party resources than Oracle. And if it doesn't work, I now understand why a lot better because I know Azure very well, while I don't understand Oracle. So once I have a proven solution, I could then apply that proven solution to Oracle. So I tried the same approach with Azure. It helped a little bit. It also told me in some cases that, hey, they failed to convert this resource. It didn't mention that in the response, but it mentioned it in the code. This was better, but it was still useless, pretty much. It failed to convert most of the resources. And it did a much better job with the application layer. It actually did a pretty good job converting from Azure to AWS. And because my application layer was actually using the AWS SDK 2, it actually converted it to AWS SDK 3, which saved me some time, which was nice to upgrade to a new SDK version. But there was a lot of changes I still had to make, and there's some details here. The verdict was it was somewhat helpful, but in order to make it operational, I needed to understand some cloud-specific things, which I did. But a lot of the people who want to apply this kind of concept do not have that cloud-specific knowledge. And honestly, the question that I then came to is, wouldn't have it been better to just rewrite the whole thing, considering how many tweaks I had to make manually? These are all the changes that I had to make manually in order to get this working. Quite a bit of work. So then I said, you know what, let's change the approach a little bit. Let's try to change these resource by resource. And I was kind of shocked to learn that it did a better job when I gave it one resource at a time than if I gave it the entire code base, which is kind of weird because you would think with more context, it would do a better job. Well, this was helpful, but it was very tedious and once again required some cloud-specific knowledge. Okay, so now let's go ahead and look at some tools that are specialized for code. And one of the big topics this year is agentic AI code editors. In the time that I have started this conversation, there's already 5 new agentic AI companies that have been formed, and they've already been valued at $100 billion because everybody and their mother is launching a new agentic AI solution. This is going to embed into your integrated development environment, or it is going to replace it altogether and allow you to write code using AI. And this is what people call vibe coding, where not only are they having the AI generate substantial portions of the code, in many cases, it's writing the entire code base, because a lot of the people that use these tools don't know how to write code at all, have no computer science background, no programming experience, certainly no security experience. And this has definitely raised some security concerns, although these have been widely debated. And frankly, a lot of people are blaming vibe coding on problems that are not related to vibe coding. You may have heard of this breach for this application called T that happened a couple months ago, and everybody blamed vibe coding, and it was like a lesson in why vibe coding is bad. It had nothing to do with vibe coding. If you'd like to learn more, check out the talk that I did with the Internet Storm Center on YouTube about T. Just look up T, Brandon Evans, it'll come up. It had nothing to do with vibe coding. It had to do with one of my favorite technologies to talk about, Firebase. But that's a conversation for another time. Here's a funny little post on Twitter that I loved on this subject, where someone used Claude 4 to refactor their entire code base. It modularized everything, broke up monoliths, cleaned up spaghetti. None of it worked, but it was beautiful. That's oftentimes the result you get. Now, the first one I tried out with was Cursor. And I was honestly blown away with how well Cursor worked for me. I think part of the reason is that, at least on paper, Cursor claims to use different models for different use cases. So you give it a prompt and it'll decide which model to use of the models that you've enabled based on the prompt. And that's pretty cool. I don't know how much of that is magic and pixie dust, or if it's, a lot of marketing hype, but it did a really good job. And in fact, I only got a single error when I did this deployment, and this error message actually makes sense in the context of this conversion, because this ACL is just simply not compatible with the way that Oracle handles this particular issue with flow logs. It was a very reasonable mistake for it to make. And it made some reasonable errors and omissions. Some of the structure was odd. There's some startup scripts that I wrote that are, not very cloud agnostic. And as a result, I had to make some manual changes. But overall, it was very, very valuable. It really helped me out. But one thing I'll warn you is I know that Cursor and all of these different AI programs are really increasing their prices. I think that a lot of these prices are artificially suppressed right now to help get people locked into these platforms. And with time, I think the services are going to get slower and more expensive in order to handle the demand. So if you think that Cursor can replace your engineers, consider that in the long term, your AI might be more expensive than engineers, or at least more expensive than a single engineer. But there were plenty of problems that happened. You can read more of the details here for during the recording. But basically, the conclusion is that you really have to understand these cloud providers in order to use Cursor effectively. I also tried GitHub Copilot. GitHub Copilot actually dragged their feet on the automatic code editing process. There was a feature a feature request that was opened about the subject, about how people wanted to automatically modify the files. And someone complained about this by saying, I'm too lazy to create files in 2024. And that attitude should be terrifying to you, absolutely terrifying to you. So now I'm going to use Oracle. I'm trying to convert Oracle to AWS to Oracle using Cursor very slowly and very patiently. And the answer is in the grand scheme of things, I was able to convert 100% of my Terraform code with just GenAI. I had to make some other manual changes, and I had to learn more specifics about the Oracle jargon. But in order to convert the Terraform, all I needed to do was use GenAI. However, here's the first set of prompts that I used. Here's the second set of prompts that I used. There were so many prompts that I couldn't even show the entire list, and I had to install a third-party tool in order to work around this called SpecStory. So I had over 200 prompts that I needed to use in order to convert this. So the idea that this is an automated process is simply not the case. It can help, it can accelerate you. It was very helpful, but it is not manual. And anybody telling you that you can use this kind of technology in order to automate these processes and eliminate the need for your developers is simply not true. But the app ended up running mostly. For the sake of time, I don't think we're going to do an actual live demo, but the application worked just the same. And if you want to see that in the real world, we're going to have it in the new version of Sec 510, which is going live in Amsterdam next month or later this month. It's already October. Some quick things to consider about security. According to a study that Microsoft did with Carnegie Mellon, in general, GenAI is making human beings less critical about things. Like, this is a potentially evolutionary change where people who trust GenAI are less likely to use critical thinking. And this is especially true for low-stake tasks. Now, some things like this have happened historically with other transformational technologies like smartphones, but I think that it's important to understand that we do not know yet how transformative this technology will be. And Microsoft has every incentive to tell you that GenAI is not going to hurt us. And yet they said it hurts us as a species. Vibe coding is not secure by design. You may have seen this post about someone who created a SaaS product and then immediately got hacked. I'll leave that for you to read later. One of the things I want to leave you with, though, is this great quote from an IBM paper that said, a computer can never be held accountable, therefore a computer must never make a management decision. I think that this is true for any significant decision that matters for the security and operations of your organization. And yet we're moving to a world where people are making tremendous change sets, like this one over here to the Gemini CLI. Someone made almost 42,000 lines of code changes, and then it was reviewed by GenAI. And GenAI said that there's only one issue that it found. We're going to get worse and worse at code review, in my opinion, because we're going to offload more responsibility both to the development and the GenAI, both for the development and the review process to GenAI. And GenAI is probably going to miss a lot of things because it's going to say, oh, here's what I would have produced. It matches, therefore it must be secure. That being said, not all Gen AI models are created equal, and there's this great report from Backslash Research that shows which models are best and which ones are worst for the purposes of security. So no time for the demo. Going to leave you with some resources that you may want to take a look at. Because we covered Terraform in this talk, if you want to learn more about Terraform, go to sec510.com/terraform-poster. We've got some upcoming runs of the brand new Sec510 Cloud Security Engineering and Controls course. The first run of the new version of this course is October 27th to 31st. We're going to be virtual in the East Coast in December, and the new version of the on-demand is currently in pre-sale and will be available hopefully very soon. We've gotten a lot of rave reviews about the course, and they've only gotten better with our new modifications. I really like to quote Sean that says, "If you cloud, you need this course, period." And I had a lot of content to cover in a short period of time. I will not blame you if you want to rewatch this in 0.5 times speed in the future. But if you have any questions or comments, please leave them in the Slack channel. I'd love to answer them. And feel free to reach out to me via email or on LinkedIn, which I'm very active on. Back to you, Eric.